Hey, Lou Ladwig here. Going to do another little video segment on voltage regulators, and that seems to be just in watching the internet and all the chatter going back and forth, when it boils down to someone's battery not charging properly and system not running right. There's a tendency to just pull out the voltage regulator and replace it. Well, no need for that, especially when you have a World War II voltage regulator and they cost a couple $100. You can get CJ replacement ones for a lot cheaper, but they're all repairable, and that black box really isn't that much of a mystery inside. When you look at it at the get-go, it can be a little intimidating, but heck, a lot of you guys will pull an engine apart and tear it down, and there's actually a lot more to rebuilding an engine than there is to fixing up a voltage regulator. So let's take a look at what we've got going on in a voltage regulator and talk about some of the fundamental things. So this will be first installment of several on voltage regulator maintenance and repair. So let's check it out. Okay, we don't have the Sean Hannity fancy marker board, but we do have a sheet of cardboard, and we're going to show you how the voltage regulator system works fundamentally. So here's our generator, and here's our voltage regulator, here's our battery. And remember, every Jeep has to have a good ground. That's super critical. So before you go working on your voltage regulator, make sure that your ground and your cables and your wiring and all that is in really good shape. Fundamentals for doing that: you can put a VOM, hook it up on this terminal, reading resistance, and go all the way through the system to where it comes over to here, and measure how many ohms of resistance. It shouldn't have much. It should be very minimal. If you got a high ohm reading, then you've got rusty old dirty connections, old broken wires, something of that nature. Same for all the other connections. So look at the generator. All right, so we've got the armature field. There's also a ground post on there that goes to ground. Again, you got to have a good ground system in these things. And so from the field post, that's usually the big one, comes over, goes over to the field terminal on the regulator. Armature comes over, armature on the regulator. And the battery, that's that wire I talked about the other day that comes off the engine. I should have put a drop light here for you guys. Now hang on, let me get one. Okay, we got the miracle of light going here. So coming off of the battery terminal, that's that baby right there. You got your cable running down, and that's going way back in there to the that's hard to see, but the starter junction button. That's the source for the electrical for the charging system there. So let's go take a look at a voltage regulator. Okay, here's a voltage regulator. It's actually a 12-volt version out of a Weasel. So we'll take a look at it. Okay, so one of the first things is the aluminum housing and then the tin housings on the civilian models are conductive. So disconnect the battery from the system, disconnect the positive terminal on the battery, because if you lift this off and you touch any of the guts, zap, you'll short it and you can fry a terminal and run it. Okay, so there's the insides. Looks kind of complicated, but it's really not. These are just simply electromagnets. 3 electromagnets, solenoids, whatever you want to call them, that draw down and make a switch. So they're electromagnetic switches. Okay, pretty straightforward. So we've got the field, the armature, and the battery. You can ignore the condenser here. The condensers were for radio suppression, static suppression, and unless you're really doing a high-end detail on your Jeep for historical purposes, you don't need that at all. So that's the guts of it. Let's go take a look at the board one more time. Okay, the first thing what we're going to talk about today is the voltage regulator portion. That's what actually controls the amount of voltage that's going through the system and charging your battery. That is the one item that often can be out of whack. People mess with them when they try to put alternators in or switch to 12 volt, or maybe they're running an 8-volt battery, so they want to up the voltage charging the battery to 8 volt, that sort of thing. So that's the first section we want to take a look at. Okay, here in the technical manual, right there, that's there's the technical manual numbers under the description of the system. There's your voltage regulator. There's several makes and models that essentially do the same thing, but output 8 amps, 7.6 volts, 955 RPM. Here's the one that's important. 40 amps, 7.6 volts at 1460 RPM. Okay. Okay, so what you want is, well, the way the system works, to some simplified description, is at an idle, a generator doesn't put out much. But when you get up to about 1500 RPM, it starts generating 40 amps, and then the voltage a little bit greater than the battery. The current flows into the battery, recharges the battery, and so that's what we want to check. That's a very common problem with the charging system, is that is out of whack. So you can clean the terminals in the voltage regulator, because once you've cleaned them, that can change the set slightly in the way it charges. It's similar to cleaning contact points in a distributor. You want to, some people say only use metals. Some people say you can use really fine emery, like 400 grit. I've been successful with emery, but I clean the terminals afterwards. Don't leave the grit from the emery paper in there. So dampen a piece of cloth down with some acetone and rub that through there and polish the points clean so you're not leaving behind any grit residue. But so what's going to happen, the voltage regulator part, the VR, that set of points is going to cycle on and off to maintain a certain preset voltage when you're at 1400 RPM recharging the battery. So this Jeep has a Optima battery inside a Willard case. It's a 6-volt Optima, and the manufacturer recommends a recharge rate of 7.3 volts. The technical manual, I think, says 7.6 for an original World War II battery, or if you went to Tractor Supply and got a 6-volt battery, that would probably work too. Anywhere in that range, 7.4 to 7.6 would be good. You don't want to go much higher, because then you'll cook your battery and you'll get all that acid vapor boiling out of there. Your battery won't last, it'll toast, and all that acid vapor will go eat your engine bay and your battery tray and all that kind of mess. So you can test that charge rate, and I'll show you how to do that. Okay, make sure your engine's warmed up, and here she's at an idle. Alright, so she's about 600 RPM. So just take a volt ohm meter. Here's one cheap Radio Shack one. My darn pointer doesn't go back to 0. But there's 6 volts right there, 8 volts there. So at an idle, she should be just a little bit above 6. So we're going to put that on the positive. I've got the negative hooked up. Yep. She's charging. Alright. Okay, so she's idling along here. I'm going to pull out the throttle, rev her up a ways. That way the generator is doing its thing. There we go. So it's charging there. And that's what you're looking for, is about 7.3 with the engine revved up a bit, about 1500 RPM, and that tells you that the circuit is working. Let's say it's at 7.8 or 6.2 or whatever, then you can come over to your voltage regulator And remember, it's going to be the field one. And if you look at this thing, there is a spring on the back side, and down here this is a little adjusting wheel on a threaded rod, and you can very carefully adjust that. It doesn't take much, you know, a quarter, half turn sort of thing, but make sure that all of this isn't corroded and in bad shape, that your contacts here are clean. They're just like the same kind of contacts in a set of ignition points, and that, you know, this one's a little bit corroded inside. It needs a restoration. So, but you can come back here on the back side of that thing and adjust that little thumb wheel, and you can do that while the Jeep is running. Just be careful not to bump anything with your tools and short stuff out. So you can dial that in and get it set right at where it needs to be, according to the technical manual, and get that thing charging just right. Now the armature and the battery terminals, they go to these terminals. So that's the current regulator and the cutout. And I think we've talked about enough for today. We'll try to explain those on another day, but this one is the one that probably gets tampered with the most and has the most issues for people. So, and again, before you go messing with any of this, like we talked about the other day, make sure your ground is good, your cables are all good, all your wiring's in place, clean, solid, wired correctly according to the diagram, and your engine's got to idle at the right RPM. You got to be able to run steady state at that 1500 RPM, so the generator kicks in, and that's part of the cutout circuit, is when the generator kicks in and out and actually charges the battery, and that sort of thing. So hopefully you can check that out, solve some of your charging issues. When you come over onto a CJ, it's the same thing, it's just a smaller version. They figured out they didn't need that big fat box, and they could make them smaller and cheaper. But essentially, you still got the same terminals down here and same color pattern: red, green, ground, field, armature, ground. Although this may be a circuit where that one is a B circuit. So that's something you'll have to double check before you dive in. So with a little bit of luck, you get her working right. It's a long video. That's why I'm only trying to do these in sections. Let's just check things out a little bit at a time and make sure we get them all running right. So if you have any questions, feel free to message me, and I'll try my best to help you out. I'm not an expert on this, just a hobbyist, just a crazy Jeep nut like all the rest of you guys. And take care.